someone misses you.
6, 7 common logs. You need a calculator for this section. And here is the first thing that you need to focus your attention on. Log base 10 of x and log x on your calculator. You have a button that just looks like this, log. That's all it says. Okay? Every log, just wait. Every log has a base. And if it does not designate the base, like this thing, it just says log x. It does not designate the base. We assume that it is 10. We assume that it is 10. Log base 10 is the base system that is common. Okay, log base 10. It is kind of like when you take a square root, like let's say I say the square root of 4, and I don't put a number in this spot. What do we assume that number is?
Whoa, 2.
2. It's the square root. Let's say I have x, and it doesn't have a power up here. What do we assume that power is? 1, right? It's x to the first power. Over here, if we have no number in the space down here for my base, what number do we assume that it is? 10. It's just, the common thing, all right? So, no base, we assume that it's base 10. On your calculator, it will just say log, but that is log base 10, all right? So, what they want us to first do is use our calculator to evaluate each expression to the nearest 10,000th. How many decimal places is 10,000th?
A big.
This is the 10th,
4.
10th, 100th,
1,000.
1,000th,
I was right. I guess 3.
10,000th.
Stupid.
Oh, she said 10,000.
It's 4,000th.
Oh.
She did say 10,000.
Tenths,
I thought she
hundredths,
was
thousandths,
like
10,000. So 4 decimal
10,000.
places. Write that down here so you can remember, because your homework assignment will have you do 4 decimal places, 10,000th. Okay? All right. On your calculator, type in log 5, enter.
I have a question. Do I have to put the parentheses back around it?
If that's the only thing that you're entering in, no. If you're entering something else, which we'll talk about later on, because we'll be dividing them, you do need to close the parentheses. But if that's the only thing you're entering in, you don't need to close the parentheses behind it necessarily.
Okay.
Okay? What do you get?
6989700.
0.6989?
Yeah.
897?
69897. Yeah.
So 6990, right? If it's 0.69897, this 7's going to round that 9 up, which is going to round that 8 up. Yeah? Do we know how to round decimals? Okay. 0.6990. Okay? Good? Happy with that so far? Log of 0.3.
Why did you round the 8?
Because the 7 is going to round the 9 up, but you can't go higher than 9, so it turns it to 0, but that's got to round the 8 up, right? Yeah? Okay, what is log of 0.3? Type that in. Give it to me.
It's a negative.
52287. Okay, so 4 decimal places. This 7 is going to round that 8 up. So negative 0.5229, yeah? Good? That's easy enough, right? Give us a bunch of those, right?
Of course.
All right, let's go down to...
Hang on. Go back.
Hang on, go back. Okay, got it. All right, moving on to story problem. The loudness in decibels of a sound is written by this equation here. Okay, let's talk about what these variables mean. What does L stand for? Loudness. Loudness is that variable. I. Read further. What does I mean? Intensity. Okay, what does M stand for?
Minimum intensity.
The minimum intensity. Okay, like minimum intensity of sound. I am old. You are young. You guys can hear some sounds that I cannot hear. Did you know that?
Yeah.
Okay, like the really, really high-pitched noises and stuff. Your ears can hear those, some of them, and I cannot hear those because I am old.
Yep.
The older you get, the less you are able to hear, and then those pitches like change, okay? So the minimum intensity kind of focuses on that number, okay? What?
So have you ever went to a house and they have a think it's a fire alarm that just beeps for no reason? I have.
Oh.
And the other people can hear it, and I was so confused.
I don't know. You just have good ears, I guess.
No, it's kind of like
Okay.
the thing of where like city people won't hear the train anymore. But if you go to the country,
Because you're used to it.
like the car noises,
Alright.
you won't fall asleep because you're so used to the car noises.
Nice. All right. Residents living several miles from a concert venue can hear music at an intensity of 66.6.
Oh, I don't.
Okay. How many times the minimum intensity of sound detectable by the human ear was the sound if M is designated to be 1? Okay, so we've got two things to plug in. We got to find out where we're going to plug them in. M is 1, so that's going to go in here. But where does the 66.6 go in? I. So what are we solving for? L. All right, so let's do this. 10 log of 66.6 divided by 1. Do we have to do 66.6 divided by 1?
I need to.
Kind of.
Yeah. That's just 66.6. Okay? So type in 10 log. What's going on between this 10 and this log if you need to put an operation in there? It's really like 10 times log of 66.6 if you want to put a times in there. Otherwise, you can just say 10 log, and that's fine too. Okay? Type that into your calculator. Tell me what the loudness is. How loud is it? 18.24?
Yeah.
24.
Wait, no, 2347.
23. Okay, so 18.23 is the loudness. Okay, so the minimum that we can hear is 1. So that would be like a whisper or like that really high pitched thing. 18 times that sound is what these people are hearing. Are they at the concert?
Yeah. No.
No, they're like miles away and they can still hear it at a loudness of 18. We looked this up, 5th period, and they said that the world record for a shout was a teacher yelling quiet at her students. She was trying to set a record. She wasn't actually like trying to be mean to them, whatever. But her loudness was a 121.7 was the scale that she was on. That's the loudest yell that's been recorded, I guess. So they're hearing it at an 18, okay, which is not terribly loud, but take into consideration that they are several miles from the concert. So they're actually hearing a decent amount of noise from this concert, right? If the loudest shout possible is a 121.7.
So, like, during homecoming, because people across town can hear it.
Right.
Town isn't that big.
Yeah. So that's not several miles. That's not several miles. But they're probably hearing at an intensity of 18, maybe like 20 or something like that, because they're a little bit closer. So, anyway, that's the deal. Okay? Makes sense? Good? So, 18 times larger than what a whisper or what like the minimum sound would be. Good? All right, example 3. We have 3 examples left. Example 3 says 4 to the x power equals 19. That looks really short and quick.
4.
Okay, nope, we can't divide by 4 because it's 4 to the x power, not 4 times x. It's 4 to the x power. Okay, so here's the deal. If this said 4 to the x equals 16 instead, okay, what we could do is we could look at these two numbers and say, okay, I'm going to change my bases, right? 4 to the x power, I could make 16 say 4 to the second power, right? And then what happens to solve for x? You cross out the 4 and x equals 2, right? That's if that was 16. But it's not, it's 19. So we have to figure out how many times do you take 4 times itself to get 19? Crap, you can't do that, right? It's going to be a decimal. Oh my gosh, whatever. Okay, you can't take 4 times itself any whole number of times to get 19. So what we do instead, this is how we solve these when they don't come out nicely, like the 4 and the 16. Okay? What we do is we insert a log on both sides. So we take log of 4x and log of 19. And if we do that to both sides, then it's legal, right? That's how we solve that, okay? Now,
We don't like things that are legal.
from this point, this isn't hard. From this point, now that there's a log there, we have a little rule that says if there's a log, this x that's in the top here, where can he go?
The front.
To the front, right? And so really this is kind of like saying x times log of 4 equals log of 19. And you can put the parentheses or you don't have to put the parentheses. And I want to solve for x. So how do I get x by itself? How can I get that x by itself? Divide by
Is that just your solution to everything?
log 4.
Wow.
Four.
Divide by
Divide by 4.
log is a little bit different than 4. You're dividing by log 4. So x is equal to log 19 divided by log 4. Now, you do have to include the log in both the top and the bottom and. This is answering Sarah's question. Just wait. Answering Sarah's question that she had earlier. This is a good point. Your calculator, some of you, when you type in log, it will open up a parentheses and you type 19 in. If you are then dividing by log 4, you have to close the parenthesis off on the 19 before you divide by 2 or divide by log 4. Does that make sense? Okay, so try that in your calculator. Take log of 19. If you open parentheses, you got to close them first, then divide by log 4. Okay?
Just tried spelling log with a 1 and a 0.
You use the log button. Okay. 2.923?
No.
I got 2.12.
I got
2.12.
1, 2,
Oh,
2.123.
1, 2.
7, 5,
1, 2, 4,
6,
technically.
7.
But we're doing 10,000th, which means 4 decimal places, so
Yeah, 1, 2, 3. Because it's 1, 2, 3, 9, 6.
oh, 1, 2, 3, 9, 6. Ooh. So this guy's going to bump him up, and that's going to bump him up. So 2.1240. Right? That's what he will be. Rounded to 4 decimal places. We gotta round up. Yeah? Good? Whew. Okay. Moving on. Okay, are we happy with that?
No.
Okay, this guy. Here's my less than symbol. Less than symbol, we're going to treat it like it's an equal sign, whatever. Okay? What are my 2 base numbers?
3 and 7.
3 and 7. Can you get those to be the same base?
Yes.
Like 3 squared is 7. Right? That's not going to work. So what do we do to both sides? You insert the log. So log of 3 to the 5y power. We're solving for y now. Log to the 7, or log of 7 to the y minus 2 power. Okay? All right. Same procedure again. Just kind of uglier. What do we do now? Move the 5y to the front and the y minus 2 to the front. Okay? So 5y, I'm going to put him in parentheses. And log 3 comes after. Less than. Y minus 2 goes in the front. After log 7. Okay? A little bit uglier because we have variables on both sides now rather than just on the one side, yeah? Okay? To do this, the easiest thing to do here is let's... What?
By log 3. Yes.
You want to?
Yes.
I guess. If Kyle wants to, then no.
I mean, you could, but I don't know. Let's do it this way, and then I'll go back and show you what Kyle's gonna want to do. Okay, so log 3, I can type that into my calculator, right? What is log 3? It's a decimal. Give me 4 decimal places. What is log 3?
4771.
4771. Okay, what is log 7?
0.8450.
Okay, like that. All right, so I have 5y times this thing is on the left, right? 5y times that thing. Can you multiply the 5 and that together? What's 5y times 0.4771? Take 5 times 0.4771. It's like 2 point something. 3855 with a y after it, okay? Is less than, now what do I do on this side? I have a y plus, or y minus 2, and then I have this number. Multiply it for both pieces, right? What's that times y? What's 0.8450 times y? 0.8450y. You betcha. Okay, what's 0.8450 times negative 2? It's like negative 1.6 something. 69 even. Okay? All right. Now we've got some decimal numbers. But this is just basic algebra, right? I have 3 pieces. 1, 2, 3. 2 of them have y's, so this one and this one, and I want to get them together. Subtract which one? Okay, sure. I want to subtract the 0.8450, so does Sarah. Move that guy over to here, minus 0.8450. Just like an algebra problem, but really ugly numbers, right? So he's gone on the right side. I've got negative 1.69. He's left over. And that thing on this side, what's that decimal going to become? 1 point something. 5405. Okay. Y. And now what? Last thing. What's the last thing you have to do? I want to get the y by itself. Divide by 1.5405. This is as ugly as it's going to get. Okay. In fact, I'm pretty sure your homework assignment problems are way not that ugly. But that's as ugly as it could get. Okay. What's negative 1.69 divided by that other decimal number? Like negative 1 point something.
Negative 1.09704641.
Yep, 1.0970. That's what he looks like. Okay? Now, what's the difference between the less than, greater than, and an equal to sign?
Equality.
It's an inequality, right? So we're saying any numbers less than y will work.
Do you
But,
have to switch the sign?
but, do we have to flip the sign? When do you flip the sign?
Multiply by negative.
When you multiply or divide by negative. Did I do that anywhere?
No.
I don't think so. So we don't have to flip the sign in this case. Okay? Good? Yes? All right, so that's as ugly as it's going to get. So follow those steps when you have a problem that looks like that. Backside, last thing, change of base. Okay? My calculator only thinks in log base 10. My calculator only thinks in log base 10. So they are wanting me to type in log base 3 of 20. And how do I do that when it's a log base 3? I change it to a base of 10, right? I can type it into my calculator, but I have to change it a little bit first. Okay, here's how you change it. Ready? What? Okay, change it first. Log base 3 of 20, okay? Let's guesstimate what this is going to be, okay? If I had log base 3 of 20, I would usually set it equal to x first, right? And then if I make it an exponential function, we would say 3 to the x power equals 20. So I would say, how many times do I take 3 times itself to get 20? That doesn't come out nice, right? Okay. But let's say 3 to the first power is 3, right? 3 to the second power is 9. 3 to the third power is 27. I want 20. So my answer is going to be somewhere between what two numbers? 2 and 3. 20 lives in here, right? Between 9 and 27. So I'm going to have a decimal that's like 2 point something, right? Does that make sense? Okay. So I want to actually evaluate this in my calculator. I want to do that in my calculator, and I want to be able to change it, okay? Because I cannot do log base 3 in my calculator. So here's it. Ready?
What if I can?
Log divided by log. Do it this way, because on the test I'm going to say x's, and you can't type those into your calculator.
I can.
No, you can't. No, you can't.
There's an X button
Okay.
right there.
Log on the top, log on the bottom. If I don't put a base, you assume that it is 10. Okay, now, up here, I'm trying to evaluate this guy. What number was in the basement? So he goes to the basement. What number was on, like, the main part? 20. He goes on the top part. That's all I do. So, log base 3 of 20. I put the 3 to the basement, and they're both in log 10s now. Log 10 of 20 divided by log 10 of 3. And that's all I do. Type that into your calculator. If your calculator opens up before you do the 20, you make sure you have to close it before you divide by log 3. Okay? Do that real quick. You should get, what did we say, 2 point something, right?
Yeah, 2.7268.
Perfect. We guessed that it was a number between 2 and 3, right? Didn't we say that? Because we guesstimated 3 to what power gives me 20? It's got to be between 2 and 3. Okay? That's how you change the base. Really quick and easy, right? It's just a fraction now, but they're in base 10s. Yeah? Good? Okay, that's it.
Go
I
and
could've
think
told
about
you
it.
that.
It's gotta take 20.
Yeah.
What's that?
I think that's way too much.
Okay. Okay. All right, on your homework assignment, for the people who are watching this video, on your homework assignment, skills practice, I have you do all of them. Okay, I'll leave this up here. I'll have you do all on skills practice, but, shh, hold on, shh. So the people on the video watching this, all on skills practice, and on practice side, do the evens. Okay, All on skills practice side, do the evens. Okay, there's that.